Hello everyone. This tutorial video presents on how to model bolted joints of carbon fiber reinforced epoxy, an aluminium structure, using RBE2 element connectors. In this study, the bolted structure is organized into two components, which are aluminium for the upper part and carbon fiber reinforced epoxy for the lower part of the structure. The dimension for both plates is 130 mm by 300 mm with a thickness of 2 mm. Several important steps are required for the modeling of the bolted structure. To create both plates, start by click on the geometry and select surface XYZ in the RHS window. Insert the plate dimension in the vector coordinates list column. To create a CFRE plate, update the origin value list. Insert the properties of both plates by click on Isotropic and Shell in 2D Properties. Next, the convergence test is used to select suitable elements for meshing the structure. The RBE2 element connector is selected and used to represent the bolted joints. The element is available in Toolbar, under MPC, at Meshing section. Then, proceed to Analysis and select the normal modes. Click on the Solution Parameters to add XDB results output format. Next, in the subcase options, choose a subcase parameter. Set the interest frequency and number of desired routes to be studied. Then, choose XDB in the Access Results section, and attach the result file. The results of the natural frequencies and mode shapes can be viewed. Only the elastic modes starting from mode 7 to mode 16 are simulated for this study on normal modes analysis. Different values of the natural frequencies of these elastic modes produced different mode shapes. For the next stage, the modal frequency analysis is analyzed by repeating the steps from the previous to the mesh element. Then, apply 1 Newton of a force, and select application region at node 1. Next, proceed to the analysis. Choose frequency response as a solution type. Click on the solution parameters, select eigenvalue extraction, and set the interest frequency and number of desired routes. Then, select OP2 as the result output format. In the subcase options, choose a subcase parameter. Click the Define Frequencies, and key in the data. Select critical damping, and enter the data in the modal damping section. Then, run the analysis, and wait for a while. Next, choose OP2 in the Access Results section, and attach the file. The results of the frequency response function, FRF, can be viewed. Select at node 1 as a target entity. Finally, this study shows that vertex of the aluminium plate side containing all the resonance peaks is the most suitable FRF driving point. Hopes that this tutorial could be useful and helpful for students, or engineers, or researchers who are involved in modeling of bolted joints. Thank you for watching.